All right. Hello. This will be the follow-up video to the last one I made last week. I just kind of wanted to show the current state of something I'm working on, and it's related to the megastructure of the entities in Jai, and so let me switch over. So first off, let me show how it looks. So if I build, run, this is a super simple puzzle game. It's not really it's nothing really, but you can move around this circle in the grid, and you complete the level by neighboring to every green tile on the map. So if I step as a neighbor now into this green tile, level is completed. So I do the same here. You can see how it kind of draws a line. And when I'm satisfied with the position, I press space. I get one more, right? There's a limited amount of circles, so yeah, complete. Then I can kind of do the same. I figure out where to place this one. So for this level I have to place it here, and for completing the level I go right and done. So fairly simple implementation, fairly simple game. So let's start from the bottom of the top and down. Let's just go through all of the code really. So one main file, some external modules. I use Raylib because I don't want to focus on the rendering and input. I just want it to be simple I want to try the architecture, not the low level stuff. So use Raylib for rendering and handling inputs. In the include file I'll have the H files for Raylib. Yeah, I have a shader for a simple vignette post-processing. Nothing weird. I have this font that I don't use right now, so we can ignore that. So the main file, it's around, let's see, it's 500 lines of code. So not that big either. So we define up here, I define some constants, compile time constants in Jai are defined like this. So if I were to do this would still work, but now I can't use it in this calculation since yeah, it's not constant, it's not compile time. So to this, it's compile time. So yeah, compile time constants. One, I don't know what these are called in Jai, I guess kind of also compile time, I think. So compile time, add to context, add this type of variable, add this field to the global context. So I add my entity world and name it world to the context. That's so I can do context dot world. Yeah, and here some game state variables really. The circle I moved around was the proton, so yeah, protons left, some state variables for completing a level. I did a simple edit mode. So for example, if I change this compile time constant to true, then we do rebuild, and I get put into this other mode where I can do that, I can press it, I can move it around, I can just it's more simple to build the levels this way than coding it in. And when I'm done and satisfied with something, let's do this, and then I can press print, and I print out the code, and then I just take this code, boom, I put it into the create level function, and done. Yeah, super simple tooling. So here I have a comment indicating the beginning of the entity system. So as I showed before, we have this entity world. We have a mega array of all the entities that are currently in the world and being simulated. We have this auxiliary 2D array, which maps each kind of entity to another array of pointers to this array. So it's simpler to retrieve entities of a type. A table for caching IDs to entity pointers, so it's O1 lookup time. If you have retrieved the ID once, you can look it up later again. Of course, you have to validate this and make sure you don't retrieve a null pointer if you, for example, remove an entity and then a frame later you use the cached ID. And that's why we have this dirty boolean. Sorry. Yeah, I added this. I'm not sure about this at all, but for example, if I have this grid being drawn, and it's not really an entity. Like, it could be an entity, it could be a grid entity, but that doesn't really fit in my opinion. So I added something called systems, and in general, systems in an entity component system operate on components of data. So like a physics system would retrieve all rigid body components and update them accordingly. But in this code, I do that as well. But in this code, a system is something that it's simply a function that runs every frame. And a render system also simply a function that runs on every render call. So for example, I have this. Let's show how this looks. So for example, I add my render grid system in the main initial setup, and this is simply a function that draws lines using relib. And this function gets called because it's in the render system's array, and each time I do, let's scroll down, each time I do here, entity world render, it first renders all entities, and then it asks all the render systems to do its thing. Something worth thinking about here is the order. So if I do this, there's a difference because no, let's remove edit mode. Now the circle is on top of the line. Same for the lines here. Let's go back down. But as it were before, like this. Now the circle is underneath the, yeah, so you see. I'm not sure how in a real ECS you wouldn't have this really, because the systems is all that it's up. You don't call update on individual entities. So that's kind of something yeah, that's the thing here. Yeah, so you add these arrays and the function gets called every frame or every draw call. And then we have the entity. So mega struct for this game, for example, this is all the fields that are needed for both the tile, the green tile, and the circle. So for example, both use color, both use grid position, both will use, I think that's it, that's both, they share scale also. But for example, these two variables, they are only used by the square. And these, let's see, yeah, these variables are only used by the circle. But that's fine, because as I said, the approach here is simplicity over something that's complex, or yeah, more complex than this. This is a super simple implementation. What you would do in a real ECS is that you would have components. You would have, for example, let's say we have the circle component and a square component. These fields will be stored inside the components, and then you have like a, I don't know, transform or grid transform component that stores the grid position. And you would have a renderable component or something that stores the color. Yeah, but here megastruct, all fields in one struct. Yeah, so a way to differentiate, since it's a megastruct, we need something to differentiate two different kind of entities. We need something to tell us if we're operating on a tile or a, as the circle here is a proton, I don't know. The circle is the proton. So we need something to indicate a difference, and that's by storing a kind, the entity kind field. Yeah. And let's see, yeah, the usual init, all we need to do here is init the table, and then the init, we init the table. I'm not sure if we would need to do like an array reset potentially here on the, let's see, world.entities, maybe. I don't know. We should probably do that because it is a growable, it's a dynamic array. True also for these two. So we would probably want to do something like this. Just to be correct. I'm not sure what array reset does, so we can actually check. Yeah, it frees and it sets count and data to null. Since yeah, so this is correct. We need to do this. Yeah, and the update called every frame on the entity world, and we check. As I said, we have this dirty flag. So if we have done update dirty, it becomes true when we, for example, we add an entity or remove an entity. We say that the world is dirty, indicating that we need to update and rebuild the arrays. So this rebuilds the cache. Let's see, up here it's the cache and the entity groups. Yeah. And then we do update systems and update entities, which is reverse order here. Okay, let's do that. Yeah, so update all entities, update all systems. And the way that, for example, two entities that are of different types, the way that they can have different update functions is that I store function pointers in the entity. So I store an init function, an update, and a render. That way they can handle their update and renders differently. But for example, all green tiles would have the exact same render procedure, but the square has a different render procedure. And this is set up when you create the entity, you assign these function pointers. Yeah, and each of these functions gets passed the entity they're operating on. So it's very similar to a method, really. This is the this pointer from C++. Yeah, so add, remove, so we add entities, we remove entities. Super simple stuff. The rebuild, we rebuild the cache, we rebuild the groups. Yeah. And then the get by ID. I'm not sure if this is used. This, for example, up here in remove, we could use the cached ID, and we could. I'm not sure how a table works. Can we do this? No, cached ID. I think table get. No. Table find. Table is word cached ID. And the key is ID. Index. We have an ID Oh, sorry, this is off track, but so the table stores entity ID to pointer. So this would be removed by value, and this would be entity. Sorry, entity would be this. Why is this complaining? Yeah, one namespace is to table. So table find. And this is not the same because ID is an int64. Right? What is table U32? This would be entity. Here we go. Yeah. So this would become, instead of doing this, which we did earlier, which is O of n, linear to the amount of entities in the world, we can look up in constant speed. Yeah, we can remove this function. I think. Yeah, this one is old and not needed. Yeah, so that's sort of it for the system, like the overhanging system for the game. As I said, super simple. And just to kind of demo this in another example, let's go into another here. Let's see if I can actually figure out how I built this. It's not like that. Something like that. Yeah, and name. This is the very old one. Will there be like a, here's an exe. It's dark. Oh, I think I know where it's dark. We need to do source. There we go. Yes. Oh, what happened here? Oh, I think there's a light. Yeah, there was a light inside this one. I can't press this one. Yeah, so this is using the same system with some other, it's 3D and it has some other type of entities. It has lights, each light is an entity. I have some dev tooling. I can add other stuff. This is an entity of kind prop with an ID of 5. This is an entity of kind light with ID 2. I can display the position and so on. So what I tried to do, let's see if I can. I just kind of spammed just to see if it's even maintainable to use this kind of system. Like how many big 3D entities of course they are not simulated at all, but I think I spawned up to like a couple thousand, and there's no problem iterating over that many entities, keeping like 60 FPS. Oh, this is an enemy. Alright, I made some enemies that kind of follow you around, like scary, kind of scary. So I can press these lights, I can move them around, I can pull them up, I can move this right here, I can make it super red, scary, and I can let him follow me. Yeah. As I said, this uses the exact same setup as I showed before. I made some small changes in the new implementation. can do this. I can copy it as well. I can fuck around with the lights. I can change it up a bit. Red, green. I don't like green factor. Like that, maybe. Yeah, kind of cool. I can create other entities. I can press them. This is a prop. Then I can have a keybind to transform, rotate, translate. I can move them up and down, I think. I can have a flying trash can. Yeah. I don't know. Just wanted to show the system. So the plan is to use this system for real in the upcoming game jam. Let's see. This game jam I'm gonna show you. The Game Maker's Toolkit game jam. This one. It's a super big game jam, and people are going to be using all sorts of stuff. I think a ton of Unity games, ton of Godot games. So if you're planning on joining this event, and if you're planning especially on like trying out a low systems level language, like Jai or Odin or something, feel free to leave a comment. Maybe we can talk during the jam or kind of bounce ideas. Yeah. Alright, I'm gonna end this here. Kind of short, but yeah, thanks for watching.